Hello everyone. Welcome to my presentation about Unreal Engine 5 server optimizations. To give a bit more time to questions, I think we should get started. So, let me introduce myself. My name is Juan Gomez. I joined Sperasoft in 2016. In 2019, I became a lead developer. I work in games like Mortal Kombat Mobile. In 2021, I became Associate Technical Director, and I work in games like Ubisoft's Defiant. And in 2023, I started working on Shrapnel. A bit about Sperasoft. So this is a codev studio. Okay, sorry, something wrong with my slides. It has studios around Europe and 700 employees. It's part of Keyword Studios, which is a well-known brand that helps other companies to make games and works in multiple engines and software. A bit about Shrapnel, for those that don't know, is a multiplayer extraction shooter developed in Unreal Engine 5, 16 players PvP, with plans to have more. I run on a dedicated server and currently in early access in the Epic Games Store. So what are we going to talk about today? First of all, this is a talk about CPU and CPU profiling and CPU optimizations because it's focused on the server. It will be technical, focused on engineers, but I think anyone in the team should be able to follow and hopefully benefit from it. First big part of the presentation will be about character optimizations for character movement. Then we'll talk about animations. Then we'll talk about replication, and lastly, other optimizations. So let's begin and let's talk about Unreal Engine 5 server profiling. So before you start profiling, there is always a few things you should consider. So first of all, what build should you use, for example? Another question that you should ask yourself is, what should you profile? And lastly, where should you profile? So these are key questions to ask yourself and understand that personally I believe there is no right answer for this. It's important that you find what's comfortable for you, what fulfills your needs, and that you understand limitations of it. For example, development versus test in Unreal, and that you don't mix results from one group to another because you're going to get incorrect conclusions. For this presentation, we were basing ourselves in development traces that I took myself. And they were in Windows, even though our server runs in Linux. So let's talk about the tools briefly that we use. So obviously we'll be using Unreal Insights. It's a well-known standalone application provided by Unreal for profiling. You can use it to profile CPU, GPU, memory, networking, and many other things. And in our case, for CPU profiling, there are two things that we care about. So first of all is the average FPS that we have, but we shouldn't forget about our spikes and bottlenecks, which are these tall vertical lines that also affect potentially player experience. And this is how your trace may look like once you have you're done your job, but if you start profiling, probably it will look something more like this. So this is one of our first traces. As you can see, the server is struggling to hit 10 frames per second. This is even lower with big spikes. And this is a talk to see how we can get this to some stable frame rate. If you want to know how to use Insights and you haven't done before, you can launch it through Visual Studio or Unreal Games Inc. And once it's running, you can start profiling. You can do it via the editor in the user interface, or you can do it via the command line argument when you open the game. There are cheats that you can use as well to start and stop the traces, and by default I will say that it runs if Unreal Insights is open. But you should be aware of this stat name events parameter, which will give you actual additional information that you may miss otherwise. Another tool that we use is Unreal Network Profiler. It's a bit older tool, but still has its uses. Obviously, it's mostly used for network, but it can be used to profile also CPU that you spend on replication. And you can see it here, CPU profiler, waste column. We'll get into details later. To launch it, you should do it through the precompiled binary, and you can start and stop your trace via command line, and then access it in the folder that is saved by default. A few things about Unreal Engine server that may not be known by everyone. First of all, it runs 30 frames per second by default. It skips, obviously, all the stuff that server doesn't care about by default, like rendering, sounds, VFXs, UI, etc. But it runs things that affect the gameplay, like physics, blueprints, animations, etc. Even though physics and animations are traditionally multi-threaded in the client, in the server, everything runs on one thread. This is on purpose, so you can have multiple servers on the same machine without each other affecting the performance of the others. And lastly, I will say that the cake is a lie. Actually, the plain editor is not a good way to profile your game. You will get a lot of mixed data, and only recommend it if you are actually having performance issues in the editor. Otherwise, you should always use package builds. All right, so let's talk about first big piece of optimizations that we're looking at, which is character movement. So here we have a trace of that initial performance graph that I showed you. So as you can see, there is 3 big pieces. I like this one because even though the server performance was very bad, it shows the things that we care about mostly, which is the first group, green on the left, is the character movement. In the center, we have animation, and the last is replication. So what do we have here, actually? So in the center, you can see each of these columns is actually a character, a player. So we have 16 of them. And here on the left, we have RPCs from the client. So every tick, a client will send to the server information that they have moved and where. And because, as I said, the server runs at 30 frames per second, it will queue these RPCs and process them one by one when it's ticking. And because of that, if the server is struggling, they will start queuing more and more RPCs, which means it will struggle more and so on. It's like a snowball effect. And here you can see more than 100 RPCs queued, and it's terribly affecting the performance. So the simplest thing you can do here is enable move combination. So move combination is a feature in the engine that once you have enabled, you can start using the modify the set move frequency. Basically, what this means is instead of sending updates every frame, you can say, I want to send updates every 30 times per frame, per second, sorry. Or if the character is not moving, even less, so 15 frames, 15 FPS. And once you've done this, you will start seeing the results. So here we have a similar trace where you can observe 10 plus characters in the center, but only 6, 7 RPCs that are being received on the server. And just by doing this, we got the server to some stable frame rates and more decent performance, almost not changing anything else. So what's the thing about this type of solution? It's simple to enable. It leads to less server CPU usage, and also, thanks to side effect, less network traffic. But it has some negatives. So first of all, it doesn't really address the main problem, and this is kind of how many Unreal Engine optimization features work. It could lead to potentially worse movement replication because now we are just sending less data. And lastly, you could have some bugs in the client due to how the client starts combining the movements. So when it's time to combine, it will undo and redo a bunch of stuff. And depending how your game works, you may find some bugs. We found some. They weren't huge, but worth mentioning anyway. So what are the next steps? So as I mentioned, we didn't fix the main problem. And the main problem is, like, after receiving the RPCs from the client, we're doing a bunch of stuff. And a lot of it has to do with animations. Animations which anyway, in the next RPC, they will be undone. There is also animation blueprint tick coming later. So let's talk about how we optimize animations on the server. So in our project, we use advanced locomotion system. This is a plugin that it was fairly popular some time ago, but I don't think so much anymore. There are a bit better systems nowadays. There are also flavors of ILS out there, but we have our own modified one that was added replication and some other optimizations. And you may be thinking right now, why do I actually need to play animations on the server? And there may be a few reasons for this. So first of all, hit registration. You need to, if you want to at least validate hits, projectile hits on your server, you may need to have the correct pose. So the capsules that are attached to the character, they are in the correct place. Secondly, there is anim notifies, which may have some logic. So anim notifies are triggering while the animation is playing and may do things like, I inserted a bullet in my shotgun, right? Now, I will completely advise against doing that. We had a lot of problems with anim notifies because the animation in the server may run at a different speed or blend differently, so it may lead to anim notifies not being called or called at some different time. And lastly, there is root motion. So the position of the character may be modified by the animation itself. And if you don't play the animation, you should somehow have room motion active or handle it differently. So if after checking this, you decide that you still do not need animation on the server, there are few things you can do. I guess the easier is check this optimization in the actors, which is a visibility-based anim tick option. So you can select only tick pose when rendered. The character is never rendered on the server, therefore it won't tick the animation. A few notes about this type of change is that if you just do this, it will affect both client and server, and you may want to change it in some more smart way in the code if you only want to change server behavior. But anyway, it's a good optimization for the client as well, especially if the characters, other players are far away and you don't see them. I will say that shadows and other things limit the effectiveness of this cooling, because even if you don't see the character, he may be behind some wall and you see his shadow and it still needs to be in the correct pose. Lastly, we observed that things like sequencer alter this value every tick. So if you're using sequencer, you should be aware and maybe just be careful that you change this value. Why am I still consuming resources? It may be sequencer or something else. All right, so let's look at one of the traces. So this is the tick for one character, and you can see that our biggest bottleneck is animation, and in particular, blending, blend poses. So blend poses is the first thing we'll look at. So to understand why blend poses can be expensive, first we need to talk about our skeleton. So we have in our game a metahuman skeleton, which has 342 bones, and you don't need so many in the server actually. You only care about the 22 physical bones that or whatever bones your capsules for collision are attached to. So the first thing you can do is something like this. So let's have only physical bones on the server. So in this particular example, we did some small engine change in compute required bones. And here we check if we are on a dedicated server, we reset the bones previously calculated, and then we will just return the last ones, which are the physic bones. And this is kind of like maybe not always recommended way to move forward, like changing the engine. I left it here because it has some advantages, like, well, animators will not have to care about this, or any technical artist will have to do particular setup of loads or stuff like this. And you make sure that in the server there will never be calculations that you don't want. But if you want to do it differently, there is lots. And lots, obviously, for many different systems. So first of all, you can use lots for your character or metahuman if you use it in here. And also per blending. So here you have the animation blueprint graph, and each node has its own load threshold, and you can change it. You can basically, depending on how important this blending is, because maybe it's just for the fingers or something like this. One important note about lots is that by default, the server uses the highest lot, and you need to change it if you want manually to force a different load on the server. So here you see how you can do it very simply. If you are on a dedicated server, set force load to whatever maximum or something that you have configured in advance. More about blending optimizations. So one of the most expensive blending optimizations is the post-processing blueprint if you use MetaHuman. And it has its own value for lots that you should configure. And it will have effect if you set it on the server, like I showed in the previous slide. Another way to deal with this is to go directly to the node in the anim blueprint and check, is this dedicated server? No, then don't blend it. Or take the default pose, right, without the post-processing. The post-processing, by the way, is just like skin modification, it's purely cosmetic. And one thing about this type of approach I will mention is that if you are using this blending for cases where it's a Boolean based blending or alpha, when alpha is 1 or 0, you expect that, well, some of this optimization will not be, some of these blend poses will not be calculated if they won't be used at all. But actually we found that in Unreal Engine, in Unreal Engine previous to 4, so 3 and earlier, this wasn't optimized. So the way we optimize it is in the blend list based evaluation, we check if we only have one pose to evaluate, and we evaluate it and return, and we don't calculate all the stuff that comes later. And this is fixed in 5.4 in a similar way. You can just use this or the Epic solution. Okay, let's talk about something that is not blending for animation optimizations, which is blueprints. It is kind of general, but animation blueprints can have logic. And what we did as an example, simple one. So here we have 250 microseconds. We just moved this logic to C++. We didn't change it much, and suddenly we have 50. So it's so that, you know, you shouldn't have, if you see bottleneck in a blueprint, the first thing you should do is change into code and then optimize it from there. Another thing is animation layers. So in advanced locomotion system, the animation layers are handled through a state machine. So that means that if we have, we can have a pistol layer, we can have a, I don't know, gun layer, a submachine, rocket launcher, whatever, and they will all be, you know, waiting to be used in the state machine, but only one actually at a time. You can see how they are on the top used, like they are all present. What we did was change this to have only one layer at a time using the anim layer interface. Loading them and loading them at runtime. So this is the simple thing that you should do, and I think this is the Lyra approach if you're familiar with it. However, we found some engine memory leak in this approach. So if you have an anim layer which has another linked anim layer to it, and you start loading and unloading the first one, the second one stays there. And it leads to hundreds of, you know, layers that are not doing anything. And so the fix for this, and as far as I understand, is not fixed in mainline Unreal yet, is to do something like this. So when you're tearing down instance, check if we have any linked anim graph node properties and tear them down. This may not be solution for all cases, depending on your setup, but it was good for us. Okay, let's talk about some particular example. So this is one of our gameplay elements, which is an animated drone, flies around the map. So it has different pieces and VFXs and so on. So the first thing I would advise based on this example is to not go the approach where you have nested static meshes and instead use animated skeletal mesh. This was, I talked with our technical artists, some recommendation at some point to have better performance on a GPU side because you could use nanite because they are static meshes. But this is not very good for CPU performance. And I hope that after 5.5 skeletal mesh support for nanite, this will be a workaround of the past. Another thing you should look at is disable collision if possible, and especially do not generate overlap events. This is something that is CPU consuming and often not needed. So make sure that it's not enabled unless you really need it. And lastly, there is something called attached parent bound. So parent bounds are calculated when the mesh is moved to know things like visibility and so on. And if you have these components like those BFXs that are, you know, very small, they will always be inside the bounds of the parent. So check it out. This use attached parent bound, and all these calculations will be skipped. So these are some of the things that are CPU consuming. Okay, so if we want to optimize animation, what are the next steps? Obviously, I didn't mention anything about animation multi-threading. It's a big thing, but as I mentioned, in the server we only have one thread, and we're not going to get a lot of benefit from this. There is the fast path, there is the animation proxy, the blueprint thread safe update animation. All of these things are really helpful for the client. Make sure you have multi-threaded update animation enabled on your project. Secondly, there is the significance manager. So this is an easy way to configure what matters and what should be, what we should spend resources on.
So this is mostly a client optimization where we usually we're not looking at some object, so let's have a lower load, things like this. And it could be used on the server as well. So for example, okay, we need animation for hit registration, but if no one is even looking at this particular character or shooting at him, we could like stop the animation, right? Lastly, we have also the budget allocator. So this is something that is a bit more brute force. You could stop ticking completely animations if you are out of budget, and this is a way to make sure you don't never have any spikes. Okay, so next part, replication. So this is the last big part in this initial presentation, and actually, what does it have to do with CPU? So you need to know that in Unreal, we want to optimize how much data we are transferring, and those optimizations are at the cost of CPU. Additionally, default Unreal Engine replication is very naive. Basically, if something should be replicated, the engine will go every frame and check, have you changed, have you changed, have you changed, and replicate something. If not, all this time is wasted. So, and there is one more thing, which is a nonlinear complexity of character replication. So the more characters we have, the more characters we need to replicate to all other players, and it becomes a huge problem when you start to have more and more players. Basically, this will be the main thing that consumes your resources. So coming back to the Unreal Network Profiler. So this is what we care about right now. There is a column that says milliseconds. This is how much CPU time is being spent on replicating this actor, right? This is the full list of actors. You sort them down through consumption, and then you check waste. So waste means that we have checked this object and nothing has changed. So it was a waste of time. If you see 100 there, it means like this object never actually changed, and you should ask yourself, why is it here? Should it be replicated at all? Why is it happening? If you see 99 and things like this, 95, you should definitely look into those and optimize them. Ideally, there should be a 0 here, but 50% I guess is fine. Anything that doesn't look too bad. So you go top to bottom and optimize stuff. And before doing any crazy stuff, there is all the basics. So first of all, we have the replication of variables in the actor, which I will explain what each of them do. So first of all, we have replicates. So this tells the engine that we want to replicate this object. It should be disabled unless you really need it. Just make sure that no one enable it by mistake. Secondly, the always relevant means that even if this object goes far away, I still want to replicate it. Normally, faraway objects are non-relevant. And you also want to avoid using it because, well, basically, probably there is a chance that whatever you're trying to do here, it should be part of some game state or something else. Net update frequency, it tells how many times per second we want to check this object for replication. So the less, the better. Cool distance is how far away this object needs to go to not be relevant for me anymore. So the lower, the better. Here is like 150 meters. I guess it's the default one. We also have all these dormancy settings. So dormancy is, there is a few values here. So even if an object is replicated, you can mark it as dormant. That means that, well, right now, we don't want to replicate it because it's not changing. So this is a very basic optimization, but very useful. I would say even the most powerful that you have at the base replication level.
And also I will quickly mention what means this mean net update frequency. So this is a value that goes together with mean update frequency. So if we check this object and it didn't change, so we'll be checking him less often. But before you start thinking why it's not working, you need to enable this if you want to get this benefit. Personally, I think that it's not the best way to handle this, so I will discuss other alternatives. So let's talk about some example. We have this box in our game. So this is a loot box, and we have 100 plus of them around the map. Each of them has items inside, so all of that needs to be replicated. So the problem is we have 100 of relevant actors at one time, and if we have a very high cool distance, all of them are visible, and they have overhead in the CPU. But if we reduce that distance of cooling, now objects may not appear or disappear, right? Because we are going out of the relevancy or having correct state. So the solution we went for, and something that may give you an idea, maybe inspiration for this type of design of objects, is like have a bit of the replication mentality in your organization of your actors, right? So we split the loot box in two. So on one hand, we have the box, the mesh, which is dormant always and has a high cool distance. And on the other side, we have the inventory, which is the part inside, which has low cool distance, and it's only awake for replication when it's interacted. And we went from having 100 relevant actors to have maybe 10, 20, and now we have only one inventory relevant at one time or zero, depending if the player goes near enough, because otherwise he shouldn't know what is inside the box. Okay, so a bit more advanced replication system. So push model is the first one. To enable push model, you do it like this in your project, and then once it's enabled, you can start using it in your classes by marking them by isPush based. So this will tell the engine, okay, you don't need to check my class anymore all the time. I will tell you when you should check it. And so you get the access to marking variables dirty. So here we have, for example, we check when we open or close our box, we mark manually that this property is dirty. So it's the most efficient way to avoid this all this constant checking. There is a couple of things you should know about this. First of all is that it doesn't completely remove all the overhead. There is 2 overhead remaining. First of all, if this object is not dormant, it will still have some overhead, and it will still be iterated for replication. So if you want to make sure you don't have any overhead for a particular object, you should still make it dormant. And secondly, when you mark this property dirty, it will still be checked if it has changed. So it won't potentially, transfer data that shouldn't be transferred. Okay, another thing, important one is fast array serializer. So to use it, you can mark your object as a child of fast array serializer item, and your container as a child of fast array serializer. You do a bit of boilerplate code here and here by creating this struct, and you get access to something similar to the push model, which is the mark item dirty, mark array dirty. So by default, the array, the data that will be replicated for the array will be only the data that has changed. But with this approach, we will avoid the game to have to check actually what has changed. So here we can make the engine more efficient. So you should use this in your arrays. What are next optimizations for replication? So first of all, the network manager is a concept that you may have seen around the internet. It tells that okay, so let's manually replicate the actors. We have 1,000 of them, let's say resources spread around the map, and we don't want to have 1,000 replicated actors, so we'll create a manager for them, and we'll just replicate that manager, and that manager will have them stored in some fast array serializer and manage their state, and you get access to things like your own encoding or whatever to save data. We took this approach, and we found quickly problems with the limit of replication that you have per bunch, because this is a reliable replication. If it doesn't fit in the bunch, the game will basically stop. And you can change this limit, obviously, but it's not very recommended. So this was happening when you need to do the initial replication of this huge list. In the end, we didn't go with this approach. Another thing is the Unreal Engine replication graph. So this is an optimization for when you have a lot of factors. The idea is, it doesn't really optimize anything, but it helps you organize what you should replicate in a more smart way than simply distance, which is the default approach. So here you could configure everything you need to replicate 100+ characters. So it was built for Fortnite, and all the items in the map. So you can be smart and say, I'm replicating them based on game state or player state, or how much budget do you have. And also there is Iris. So Iris is the kind of evolution of all of this stuff. So it includes replication graph, it includes a push model, it includes changes to the replication, default replication in Unreal. So once you enable it, you kind of have a new replication layer. We used it a little bit, and in the end, we didn't move forward, but I would say, like, in a new project, this should be the first thing you look at. But in many cases, unless you aiming very high, the default stuff that I mentioned, push model, and it will get you pretty far. Okay, so last part of the presentation, other optimization. So first of all, we have tick. So you should be careful with the tick. Obviously, tick is called every frame for the actors that have it enabled. And here we have doors in our game. So they have a very small tick, but we have hundreds of doors. So they add up to a lot. And this is because you shouldn't keep empty ticks. So if you do something like this in your game, use tick component, and you just call super and return, because you don't need to do anything, it has an overhead. Instead, you should use this can never tick and start with tick enable and all these variables that will make sure that nothing is there is no overhead there. Another thing you can do is budget your ticks, or use ticks for like easy budgeting. So do things like check time, and if we are out of budget, we'll continue on the next frame. This is important trick because, as you may remember, we don't have threads in the server, easily accessible. So this is an easy way to spread the load. Another thing we notice is the world settings. So every sublevel has its own world settings, and they are all replicated and consuming resources. So one thing you can do easily is just disable replication for it. So do something like, if set the frequency update to 0, it will still replicate initially, but not anymore. And then you can, if you want, force net update manually, which will behave as a kind of push model. So this is another way of doing something similar. Let's talk about a bit about physics and raycast. So raycast are these checks between 2 points for collisions, which normally not very time consuming for the server, for the CPU, but you normally do many of them when you use them. So for example, I will show you data of 24 players shooting 2,000 bullets per minute, which will be in our game around 800 traces per frame. So these are the results. On the first column, we have a simple collision in the map. So this is basically primitives, like boxes and circles. And then we have complex collision. So complex collision is this, mesh / polygon-based collision. And because that can be quite different in terms of complexity, we have 3 columns. So the simpler one versus the more complex one. And this is, by the way, based on like the nanite fallback mesh, which is already a bit optimized. So as you can see first, these are the line traces. So line traces have an interesting advantage, which is that they consume pretty much the same amount of time. It doesn't matter what collision you are trying to hit. So use them if possible, because you're gonna be having the freedom to use different type of collisions. If you want to use other type of traces like boxes or spheres, you will see that first of all they are more expensive, and secondly the complexity scales with the complexity of the environment that you are hitting. So if you need to use them, keep collisions in your map simple. But at this point, I would even recommend to use multi-line and try to make a kind of box or something that will fulfill that design need. Okay, another thing I will mention briefly is logs. So if you look at your traces, you will find logs that use a lot of time, but you can safely ignore them because they are disabled in shipping by default, unless you enable them for some reason, which I don't think is very common. And lastly, we have garbage collection. So garbage collection, it's these huge spikes that appear in your server or client every regular interval of time, which by default is 61.1 seconds. And what's happening here is the perform reachability analysis. So basically, the engine is checking all the objects in the game if they need to be garbage collected. And it doesn't matter how much garbage is being collected. The important is how many objects do you have. And actors in the map count. So if you have, I don't know, in our case, 300,000 actors in the map, they will take a lot of time to process. So solution number 1 for this is clustering. You can enable it in the ini file, and once you have it enabled, you can use it to mark objects as can be in cluster. So what does it tell the engine is this object, it's not important for garbage collection, it doesn't have any references, just treat it as a one thing, right? So it's, for example, an object in the map. It should be loaded and unloaded at the same time as the map, so mark it as can be in cluster. If you do that, you will end up with thousands, let's say 3,000 garbage collector elements instead of 300,000, which is a great performance improvement. If you want to use some cheats to know what's going on, you can look at these two. Especially collect garbage every frame is very important, because otherwise the garbage collector bugs will be kind of random, and this will help you a lot to catch them. Once you catch a problem with clustering, it will look like this, and it will say that you encounter a bunch of objects breaking their assumptions. So that means that these objects have some references, even though it's not supposed to. And the way to fix this is make sure that those references, if they need to be, they are not hard references, and instead they are weak pointers. Second solution is incremental garbage collection. So you can enable it like this in your project, and once you enable it, you will see that you go from having this big tick when you collect garbage to have this load spread in multiple ticks. So this is, again, not really fixing the problem, but at least you will not have any spike. According to the documentation, you're supposed to make sure that all your pointers are object pointers and not just raw pointers in your U properties, or you may have issues. So because of this and the fact that we are using clustering, we haven't really enabled this, but it's worth looking into as additional optimization. Okay, so we're almost at the end. We have a few takeaways. so to share with you. So here we have what I recommend you think about when you add in new actors into your game from the server-side performance point of view. First of all, animations. Does this object have any animations, and should they play on the server? Also, are loads set up properly for this object and for the server? Secondly, replication. Should this object replicate, and does it have the proper relevancy settings? Can you change frequency, dormancy? Can you enable push model for it? Etc. Next is tick. Should it tick? How often should it tick? Can you disable it? Can you use budgeting? And lastly, physics. Can you disable collisions? Can you use simple collisions? Can you use the parent bounds for the components, and disable overlap events? And this will get you a long way. However, there is a bit more profiling best practice I want to share. First of all, you should find your own bottlenecks. And I guess this is the key thing for anyone working with optimizations. So this is not a recipe that I just shared. Actually, there is no such a thing. Never ever optimize based on any assumptions because someone said or I read somewhere. Like, you should always know the tools, and that's why I share them and use them to find your own bottlenecks and fix what you need to fix. Otherwise, you may waste a lot of time. Next is you should try to profile often and get data, so you act as soon as you introduce a new problem. For this, you can consider investing in automation and analytics to gather data and also to have the history. This is very important, so try to keep some history so you can come back and observe what has changed and when and how things were before and so on and so forth. So I recommend you, if you're doing some traces locally, make sure you rename them and you store them. It's very easy to say, oh yeah, check something, and then you didn't rename it, and then you go to your list of hundreds of traces and you cannot find anything anymore. And lastly, trust the team. So this is not a one-man thing job where it's like, oh, this is the optimization guy. Make sure you share what you find with the team, let them learn, let them fix their own things. So I have all my technical art or animation or VFX guys who can they're competent, they can do this. I also want to thank them and the rest of the team. I could name more than 10 names today of people who work on this stuff in my team. And lastly, I would like to thank you for coming to my presentation and listening to me. And we have a few minutes for questions. Yeah, absolutely. I'm not sure how will be the best way to do it. This presentation will be available in the YouTube channel of Game Industry Conference, and I will try to somehow get this link out. And you can, of course, reach out to me directly. Okay, so we are downstairs in the Sperasoft booth. Anytime you can come reach out to me. I will be around here if you have any more questions. And yeah, we're hiring in case you're interested as well. So yeah.